In this video, we're going to continue to look at roots and radicals. Similar to fractions, any radical must be simplified. So when we have fractions, say 4/6, we must reduce it to 2/3 to get rid of the common factors. And we call 2/3 simplest form. But for radicals, what will be the simplest form? Here are the three rules. The first rule is no radicand, when expressed in prime factored form, contains a factor raised to a power equal or greater than the index. This rule seems very complicated. I'm going to use an example to explain it. We actually already talked about this in the previous video. I just didn't say the rule. So here, let's review an example. We did it before. This will be I can do a different example. How to simplify square root of 2. So as we said before, there are two possible ways you can do this. One is the quick way. If you know 72 can be factored as a perfect square, 36 times 2, that would be the easiest way because square root of 36 is a perfect square. 2 is not a perfect square. So we can do them separately. So the square root of 36 is 6. So it's asking, and remember the symbol is asking 36 is which number squared. Of course, 36 is the number 6 squared, and times square root of 2. Again, the times sign the dot can be omitted. So that's how we do it quickly. If you can see 72 is 36 times 2, and 36 is a perfect square. But what if we cannot see that? So the other way to do the problem is you will factor it as what's said in the rule, prime factored form. This is something we learned before. We factor 72. We can do the factoring tree. 72 can be factored as 2 times 36. 36 can be factored as 2 times 18. 18 can be factored as 2 times 9. And 9 can be factored as 3 times 3. So we're going to write down all those factors. 2 times 2 times 2 times 3 times 3. And as we can see, there are 2 copies of 2 here, 2 copies of 3 here. And if I rewrite it, that would be like 2 squared, and this would be 3 squared. And 2 copies of anything has to be taken out of the radical sign, and that we would get a single copy. So say we got 2 copies of 2. When we take them out, we get a single copy of 2. And we got 2 copies of 3. When we take them out, we get a single copy of 3. And there is another 2. This 2 is a single 2. There are no more 2 copies of 2. It just has to stay under the radical sign, stay with the radical sign. And 2 times 3, we can multiply them to get a 6. So you can still get the same answer. And this way is a little tedious, but we can still get the answer. So let's see read the rule again. So the number is called with the radical sign is called a radicand. So 72 is a radicand. After we factor it and into all the prime numbers, and we need to make sure the exponent, so as 2 squared or 3 squared, it has to be it cannot be equal to or greater than the index. And we mentioned the index before. Index is like the little 2 here. Again, square root 2, the little index 2. Square root, the little index 2 is omitted. And so, for example, if you have square root, this index is 2, and then you cannot have any 2 copies or 3 copies of any number. So pretty much you got to make sure if the square root of 2, as we said before, you got 2 copies, you have to get it out. So that's the first rule. And you don't really need to memorize this long rule. All you need to remember, when you see square root of 2, you cannot have 2 copies of anything. If you have any, you got to take them out. All right, maybe we can look at another example to emphasize this. Say if we want to do square root of 32. So the quick way, of course, is if you can see 32 actually is 16 times 2, and 16 is a perfect square, which is 4 squared. And then there's a 2, which stays within the radical side. That's the quick way. But if you don't know this quick way, we will have to break factor 32. So 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 2 times 2. So we see 5 2's here. And remember the rule is, if the index is 2, you cannot have more than 2 copies of anything equal to greater or equal to, greater than or equal to. So you cannot have 2 copies of anything or more than 2 copies of anything. So we see we have 2 copies of 2, so that these have to be taken out. And we see another 2 copies of 2, these have to be taken out. And then we run out of 2 copies, and then we can leave that single 2 with the radical sign. So now what we have is the first pair will give us a single 2. And the second pair will give us another 2. And now there's a single 2 left under the radical sign. So we multiply these 2 and 2, we get a 4 radical 2. Again, we can see we get the same answer. So that's what this first rule is talking about. And if the index is 2, you cannot have 2 copies or more than 2 copies of any number. If there are any, you have to take them out. So this is called the simplest form of the radical. As you can see, under the radical sign, there's only a single 2. There are no more 2 copies of anything. So that's the first rule. Now look at the second rule. No fraction appears with a radical sign. So we can look at example. Three. So we have square root of 50 over 9. This violates the second rule, because the second rule says no fraction appears with a radical sign. Apparently we have a fraction. Now in previous examples, I always give you whole numbers like 32 or like 72. They're all whole numbers. But now if we have a fraction, that's not allowed. So how do we get rid of this fraction? What we can do is, because with the radical sign, it's a division. If it's division or multiplication, we can separate them as square root of 50 on the top and square root of 9 on the bottom. So we can do the square root separately. Take the square root of the top, take square root of the bottom. So now we're going to get square root of 50 on the top and square root of 9 on the bottom. We have to make sure now we go back to rule number 1 for each radical. So now we have 2 radicals after we split them. The radical 50 on the top, radical 9 on the bottom. For each radical, we have to follow the rule. A whole number under the radical, but you got to make sure it does not contain 2 copies of anything. So if we continue to do this, 50 is 25 times 2. As we know, 25 is 5 squared. And that's not allowed because that's 2 copies of 5. So we're going to do square root of 25, which is 5, and then times square root of 2. And then on the bottom, square root of 9, apparently it's 3 because it's 2 copies of 3. It stays on the bottom. So the top square root of 50 can be simplified to 5 square root of 2, and the bottom square root of 9 can be simplified to a 3. And now this is reduced form, the simplest form. Why? We can check the rules. First of all, no under the radical sign. With the radical sign, the number is a whole number. It's not a fraction. The answer can be a fraction, but we're just not allowed to have a fraction with the radical sign. With the radical sign, as you can see, it's a whole number, which is 2. That's allowed. And also with the radical sign, there's no more, no two copies of anything. So that's the reduced, simplest radical form. Now the last rule, it says no radical appears in the denominator. So let me look at another example. Example 4. If we have negative 5 square root of 28 divided by square root of 3. Okay, so the bottom, as you can see, is a fraction. It's a radical 3. And that's violating this third rule because it says no radical appears in the denominator. So compare the second and third rule. Second rule says no fraction within the radical sign. It cannot be a fraction. It has to be a whole number. If we look at it here, it doesn't violate, in this problem, it doesn't violate the second rule. The number within the radical sign, radical 28 or radical 3, they're both whole numbers. They're not fractions. Although the whole thing is a fraction, there's no fraction that appears within the radical sign. So it does not violate rule number 2. But it violates rule number 3. Rule number 3 says no radical in the denominator. As you can see, the denominator is a radical 3. So we have to get rid of that. Now this is a new technique that we have to memorize. How do we get rid of radical? As you can see in the previous example, square root of 9, we easily got rid of that radical sign because 9 is a perfect square. 9 is 2 copies of 3. Square root of 9 is 3. We don't have radical anymore. So here it gives us a similar idea. We can change this 3. If somehow we can change this 3 to a 9, then we can get rid of the radical sign. But how do we change this 3 to a 9? Well, since this is a fraction, the fraction has a very good property. We can multiply both on top by the same number. So, any fraction we can do that. But previously, we always multiply whole numbers. This time, we're going to multiply another radical. So there is a radical 3 on the bottom. We can multiply both top and bottom by another copy of radical 3. And let's see what happens. So this is something we need to memorize. As you can see, radical 3 times radical 3, that will give us 3 times 3. So both 3's are under the radical sign, so we can put them together. On the top, we can do the same thing. By the way, this 5 is on the outside. Don't put it inside the radical. And 28, 3 are both under the radical. Inside the radical, we can put them together. So now look at the bottom. Square root of 2 copies of 3, they can come out to become a single copy of 3, and radical sign disappears. Because pretty much this is square root of 9. Square root of 9 is 3. And that successfully got rid of the radical sign in the denominator, which is what we need. But on the top, we also have to simplify that because 28 contains a perfect square. We know 28 is 4 times 7. And there's another 3 here. 7 and 3, they are all single copies. We cannot do anything about them. But 4 is a perfect square, 2 copies of 2. So we can get this 4 out of the radical sign. That gives us a 2. So let's copy the negative 5 on the top, 3 on the bottom, and that 4 becomes a 2 on the outside. And 7 and the 3, they have to stay with the radical sign. And that would give us the answer. Negative 5 times 2, negative 10. The numbers on the outside, multiply them. Numbers on the inside, 7 times 3, 21. On the bottom, keep that 3. So the answer would be negative 10 thirds times square root of 21. So notice what we did is to multiply both the bottom by the same radical as the bottom, radical 3, to get 2 copies of 3, and then we can get rid of the radical sign.